Hello, this is Mr. Win, and this video is about analyzing graphs. Graphs have many key attributes that we must be able to identify. Here's a list of some things we should be able to find and their descriptions. Domain is all the x values used for the function. Range is all the y values used for the function. Symmetry can either be even, odd, or neither. Even is if the picture remains exactly the same if you reflect it across the y-axis. Odd is if the picture remains exactly the same if you rotate it 180 degrees, meaning flip it upside down, or you can also think of it as reflected across the y-axis and x-axis. Then we have relative maximums. Maximums are like the top of a upside down U or V, kind of like in quadratics. You know how many, their location, and the value. Remember, the location is the x part of the coordinate, and the value is the y part of the coordinate. In the maximum, you can also think about it as a point that is higher than the 2 points beside it. There could also be an absolute maximum as well. Relative minimum is the complete opposite. So you know how many, the location, the x values, and then the value of those minimums, which is the y values of those coordinates. And it's a point that is lower than the 2 points beside it. So it's like the bottom of an upside down U, or sorry, a regular U. It could also be like a V, the bottom of V. Remember, that's another word for extrema as well. Alright, then we have zeros, roots, solutions, x-intercepts. So that's where the graph crosses the x-axis. Sometimes it could be imaginary. We have the y-intercept. That's where the graph crosses the y-axis. We have asymptotes, vertical, horizontal, and slant. That's the line that the graph of a function approaches. Sometimes it doesn't cross it. Vertical is if there's a restriction. Horizontal usually shows up when we do exponential graphs. Vertical is when we do rational graphs, also when we do logarithmic graphs. And then slant is more for rational when the exponent or the degree of the numerator is one higher than the degree of the denominator, which you have to do long division for. Alright, then we have increasing intervals. The interval of x values that have the y value constantly increasing. So on a graph, you'll see that the image is going up when reading from left to right. The decreasing interval is the interval of x values. So we always talk about the x's, not the y's, where we see that the y value keeps decreasing, going down. So on a graph, you'll see the image going down when reading from left to right. We have end behavior. So if you zoom in very, very far to the left and to the right, what or where is the y value? Usually it's going to go up to positive infinity, or maybe it'll go down to negative infinity, and even sometimes there's the exact value. In limits, end behavior is a specific limit, but we also do random limits where it's approach a certain number. What does that get close to? We check that the left and right numbers must match. And then the vertex is the starting point or main point of function, usually label it h comma k. So let's do some examples. Here's a graph. So the first thing you want to do is find the domain. So the domain is all the x values used here. So we have no negative x values here because there's no point negative 1 comma anything. So we start at 0. 0 is the farthest left, and the farthest right is 11, and everything in between it's used. There's no gaps. So we could say in interval notation, which is the best, is 0 to 11 closed, because they are there. It's not hollow circles. You could also write it in inequality notation like this. X is between 0 and 11, both closed. And we also have set builder notation, where we'd say it's a set of all x such that x is between 0 and 11, both closed. Alright, then we have range. Very similar. The lowest y value is 0. The highest y value is 150 in the picture. So 0 to 150, both closed. Inequality notation, y is between 0 and 150. Set notation, y such that y is between 0 and 150, both closed. Then I find x-intercepts or roots or zeros or solutions. There's x right here at 0, 0, and one here at 11, 0. So there's 2. Y-intercept, it crosses the y-axis once at the origin, 0, 0 in this case. Relative minimums, where is it at the bottom of a U or a V? So we look right here at E. This is the bottom of a V in this case. Notice that this point is lower than the point beside it to the left and to the right. And that's the only lowest point, because that's not the lowest. Here it stays the same. That's the top, that's the highest. Lowest, does stay the same. It keeps going down. So there's only one total. It's located at x equals 5, the x value of that coordinate, and the value is the y part of it. It's the y value of 50. Relative maximums, where's the top of a U or a upside down V, upside down U? There's just one total. If you notice it, it's at D, because this point D is higher than the point directly to the left of it and to the right of it. Its location is the x value, 4, and then its y value, the value of the max, is 100. And again, these are relative maximums because that's not the highest for the whole problem. The highest value here is 150. The lowest is 0. Increasing intervals. So notice from here, from x is 0 all the way to x is 2, we're going up like this. So it's increasing from 0 to 2. But you can't include 0 to 2 because we don't know what's happening to left 0 and at b. It's kind of just stopping. We don't know. Then it stays the same. Alright, so don't say that's not increasing, decreasing. Then it starts increasing again from C to D. So C is at the location, x is 3, all the way to x is 4. So 3 to 4 is our next increasing interval. Then it looks like we're decreasing, so let's call that. From 4 to 5, we're decreasing. Remember, extrema, a min or max, happens when you change from increasing to decreasing. Then we start increasing from E all the way to G, so from 5 all the way to 7. The y is going upwards as we read left right, so 5 to 7 should be next. We stay the same. Then from here we're going down, and we keep going down. So let's go all the way from 8 to 11 is our next decreasing. Right, here's another graph. This is a piecewise function. Domain, the x's, it looks like x is used forever to the left because that arrow. Then it keeps going and it looks like it's being missed at -1, but x of -1 is being used right here. So -1 comma something does exist in the graph. Then it keeps going, then it kind of stops, but it continues right here. So there's no missing x's. It goes from -infinity, +infinity, or you can say all row numbers. Remember, infinity is always open. You can say inequality notation. You could say -infinity is less than x, less than infinity. So x is between -infinity, +infinity, but that's kind of redundant. In set builder, we just say x instead of all x such that x is a real number. Range, the lowest, it goes down forever because there's any y value you can think of, like -1000. There will be some x value that goes with it. It'll be something comma -1000. So it goes down forever. It goes up to this -1. It's missing here, but it's chosen here. Hopefully I did it right. I did not. So let me fix that. Alright, so it goes down forever and it goes up all the way to -1. It looks like it's missing, but it's actually covered. There's a y. There's a point that actually has a -1 for y over here. Like for example, that's 3, -1. So it is closed. Then we have a gap right here. There's no y value of -0.5 or 0 used. It's just missed from here to here. So our next y value used is 1, and that's closed because it's not a circle, and it goes up all the way to 5. So 1 to 5 closed. Remember, if there's a gap, you have to use a union. That's or. So it's like kind of with. Inequality, you could say -infinity less than y less than or equal to -1. That's kind of weird. So you just say y is less than -1 because it takes care of the -infinity part. And then when you say union, this is or. Then here it's between 1 and 5, both closed. So y is between 1 and 5, both closed. Here's set builder notation. Y set of all y such that y is less than or equal to -1, or y is between 1 and 5, both closed. X-intercepts, there it doesn't cross x at all, so there's none. Y-intercept, so it's one right here, that is 0, 1. Relative minimums, where's the bottom of a U or a V? Right here is 1, so it's 1 total, located at x equals 0, y value of 1. Relative minimums, there's no upside down U's or V's, so no tops. Increasing intervals, notice this increase from here, from the left side, all the way to here. So from -infinity for x, all the way to -1 for x. Right, we're talking about the x's, not the y's. We already know the y's are going up. Then it goes from here and it starts going down. It's decreasing from -1 to 0. It is decreasing. Then it starts increasing from 0 all the way to whatever this is, 2. 0. That's a mistake. 0 to 2. And then from 2 onward, it doesn't do anything. Alright. So there's it for that. End behavior. So here's how we do end behavior. It's rated like this. The limit of f of x, so the function graph right here, as x approaches -infinity. As x gets to -infinity, do you know where y is going to be? So we go left forever to big number here. Where's y? Well, y is going to keep going down. It keeps going down to -infinity. So as x goes to -infinity, y goes to -infinity. That means our graph is going down the left side. See for the other side? Limit of f of x of the graph as x approaches +infinity. So as x is going right, do you know where y is going to be? Well, if we keep going right, it's going to stay on this line right here, so it's going to be -1. So that's how end behavior works, limits work. Here's another one. Domain, it goes left forever because of the arrow. It does not skip any x's, and it goes right forever. So -infinity, +infinity, or all numbers. Again, that's x is between -infinity, +infinity, both open. And set builder, x is set all x, so x is a real number. Range, the bottom low to high, because it always goes least to greatest. Lowest is negative, it keeps going down forever. It keeps going up, it doesn't skip any y's, it goes up forever. So it's also all real numbers. So very similar. X-intercept, there's one at -1, 0. Y-intercept, there's one at 0, -3. Minimums, the bottom of a U is right here. So there's one total located at x equals 0. The value of the minimum is -3. Maximums, right here is the upside down U. So this is one total located at x equals 1.333. Should be a fraction, but that's okay. And the value is -1.815. Increasing, well, let's check. From here we always read left to right. It starts decreasing, so from forever to the left it starts going down all the way until you hit this minimum. So from -infinity all the way to 0, decreasing. Alright, then from 0 to this point, 0 to 1.333 is increasing because it's going up. And then from 1.33, as forever, it keeps going down. Alright, so those are the intervals. End behavior. As x approaches -infinity, the graph f of x keeps going upwards. It doesn't go to positive infinity this time. And as x approaches positive infinity, so x will keep going right, whereas y was going to keep going downwards, so y is going to go to -infinity. Alright, I think one last one. Here's another graph. Domain, the x is used, it goes -infinity, goes left forever, it keeps going all the way over here, then it hits this -2, but it has this dotted line. That's the asymptote. So it does not actually touch -2. So we're going to say it goes from -infinity to -2, open, then union, because there's technically a gap right there, then it continues on from -2 to the other side -2, all the way to positive infinity. We use interval inequality notation. We could say -infinity less than x less than -2, but again that's redundant. Just say x is smaller than -2. The union means or, x is greater than -2. And set builder, you could put this in here, x such that x is less than -2 or x is greater than -2, or you just say x cannot be -2. Range, the lowest is -4, then it goes up forever because of the arrow, so -4 to infinity, and -4 is closed, infinity is always open. You could say the inequality, y is greater than or equal to -4, and then here's set builder, set all y such that y greater than or equal to -4. X-intercept, there's two of them. Now I didn't mark it, so I actually wrote approximately -2.75, 0, and then -1.25, 0. The y-intercept is right here, approximately 0, -1.25. Vertical asymptotes. This is line here. Remember, it's a vertical line. This is x equals. So this is x equals -2. Relative minimums, there's none. Relative maximum, there's none. Increasing intervals. From the left, we're watching it. It's actually increasing right there. So -infinity all the way to -2. Decreasing. On the other side, -2 starts high, but it starts going lower, decreasing all the way until it hits that. So we say -2 to positive infinity. End behavior, as x goes to the left forever, as the limit of f of x, the graph as x approaches -infinity. When we keep going left, we know the y is going to be -2. And then the limit as x approaches positive infinity, so x is on the right, we know the value of y, it hits this, it's -4. And that's it for the video. Make sure you ask questions. Thanks for watching. Bye.